nice to see you all. And thank you for the previous presentation. So mine is going to be a bit more about sort of DevOps side and I would say not mathy side. I was talking to a few people before. This is not about math. This is more about doing more with less. So a little bit about me. Studied computer science, worked at Microsoft for a while, software dev for a long time, live on Maui. I'm the CTO of Purple Maya, and Purple Maya is a nonprofit based out here out of Oahu. So like I said, as a nonprofit, we're always trying to help solve community problems, focused on education, focused on technology, cultural groundedness, community connection, and we want to, as a nonprofit, we want to do more with less. So to me, personally, and also in our organization, open source software is very important. It's very powerful, what we can do with it. And in my mind, open weights LLM fits under that umbrella of open source software. So, I don't know, show of hands, people know what open weights LLMs are, should I know that? So sort of like open source software, right? Like if you imagine ChatGPT, it's closed source, open source, so labs like DeepSeek, Qwen or Mistral, even OpenAI themselves have been giving away models. So big thing a few years ago when first Llama came out of Meta, I would say a lot of people were surprised. I might say it got leaked, maybe it was accidental, but kicked off this whole ecosystem of labs, a lot of Chinese labs, but also labs around the world, publishing papers, getting open source software out there. To me, that's super powerful just to think like you can have this intelligence. It's just like software you download and run on your laptop, you run on your desktop. Okay, so what is quantization? Again, this is not meant to be a math talk. It's more like compression, right? So, like I said, I think my mindset is, how can we do more with less? So, if you think of something, so a lot of times a model will be trained in like 16-bit. So whether that's EF16 or FP16, that'll be used a little interchangeably in terms of a full-fat model. A lot of times, like if you go online and you want to pay a cloud provider for an open source model, you'll maybe see it in 8-bit. So 8-bit minor loss, about twice as fast, right? Because a lot of times when you're working with LLMs, the speed that you can process it has to do with how much memory you're pushing through. So, bits per weight, the layers you got to move from, all the different computations you got to do for different tokens. That speed really comes from your memory bandwidth and how much memory you got to push through. So this talk is focused on 4-bit. Part of the reason there is because you can get really quite smart models in like the 32 billion parameter size, 27 billion. And if you compress it down to 4 bits, that'll actually run on hardware like you can have at home or even like modern MacBooks, right? So I think this year is the first year Apple started putting 16 gigs of RAM in all their laptops. Well, hey, great, you have one of those, you can run artificial intelligence at home. However, we run into sort of this critical question. There's tons of 4-bit formats to choose from. And in my mind, I kind of wanted to dig into this, do this talk, because you can actually get a pretty big range in accuracy. So, as you can see, as you get smaller, as you compress more, you get more accuracy loss. Yeah, you get more speed, of course. But these different formats, you lose different amounts of accuracy. You also have difference in speed. So, we'll get into that. So, like, what sizes are we really talking about, right? So, if a model is trained at 16-bit, it's big, right? And we're talking, like I said, we're talking about a 32 billion, just to pick a model that came out this year, but is relatively widely supported by a bunch of software, so easy to test. This is like the full fat, right? Maybe this is how it's trained. This is how a lot of people online might host it, like if you have like a big server farm. But if you're running it at home and you want to have it smaller, you want it to be faster, and arguably maybe even use it for, we use it for real tasks, right? It's still quite useful. Maybe you're in this range, right? But again, lots of different formats to pick from. Some are community formats, some like this one are from NVIDIA and only supported on the latest cards. Some are Apple only, so like I said, you can buy like a Mac Studio with tons of RAM and it's actually quite fast enough to run a bunch of stuff. But you still gotta pick the right format. So in my mind, there's lots of different ways you can measure accuracy, and I guess caveat on this, if you're actually gonna go do this, DevOps, it really matters what your workload is. So like, if you're writing, stuff for conversation partners or stuff for restaurants, the models you pick should probably be based on your workloads, your benchmarks, as opposed to just general purpose internet ones. But the ones I picked, ones I typically look at first if I'm trying to find out how a new model is doing, I look at Ada Polyglot, which is one of the really highly regarded benchmarks for coding agents, or how models fit into coding agents. Polyglot is a harder benchmark that had gotten launched this year. Lots more programming languages, but it helps test the model's ability to do instruction following, coding, some agentic, a little bit, not so much. And then LiveBench is like actually a much bigger one. They cover lots of topics. So it's sort of, I look there for general purpose, not just coding. Speed-wise, VLLM is like industry standard way to host LLMs. They also have a benchmark. LLM perf I used a few times when VLM benches didn't like a setup. We care about things for speed, like not only single user speed, but also concurrency. So what if you have multiple tasks running at a time? What if you're serving multiple users, like an organization? Or maybe you have an agent case, right, where it's doing like 50 things at a time. Small more caveat, some of the tests are run at 8-bit size just because some of the math stuff takes forever, and to do some quant comparison, I used a smaller one when I needed a few more data points. Yeah, hardware-wise, so I do have access to a Blackwell card. It's one of the workstation class, so it actually has a little bit, it's pretty new in software support, which also has new caveats. And then one of the M3 Ultras for the Apple stuff. So inspiration, why is this interesting to me? I think it was about almost exactly a year ago, so November 2024, it kind of blew my mind. So there's a service out there, OpenRouter. It's pretty cool to go try a bunch of open source models, routes to a bunch of providers. But this blog post came out and it was like, the details actually matter, right? Like if the context size is configured too small, or the quantization is too big, or you don't even know, like you can have a pretty big difference in, as I was mentioning earlier, accuracy. And then a similar kind of inspiration, this is a blog post from this year, and this is kind of I would say relatively common idea in the like local or open weights models community, but maybe not necessarily generally known. You might actually get a lot better results from using a like very compressed big model compared to a not so compressed small model. So again, I can share all these slides. They're in GitHub, and all the data is in GitHub. But so this is talking about like these are different like quantizations of DeepSeek and how they compare to like bigger or smaller things. So like this is like a 1-bit DeepSeek, which if anybody asked you, can you compress down to 1 bit a year ago, you'd probably say that's crazy. But actually, there's ways to do it. Okay, so actual results. So in a lot of my what I was really trying to get at was like, what's the difference in formats? And so when I'm showing graphics and charts, I tried to show more the idea of ratios, like not tokens per second in most of these slides, but more how does like a 16-bit, if you consider that the base, compared to something like 8-bit, or how do all these 4-bit ones, right? So like 100% is like what you would expect for accuracy out of, what's the best you can get out of the model if you don't compress it versus, how the other things fall. And then another reason for that is to show like the blue bar is like LiveBench, so like different kinds of ways of measuring it versus Ada. So be able to like show them on the same axis. And then there's some numbers over there, kind of in the order of how accurate it is. Small, I don't know, lots of small nodes everywhere. There's tons of details we can talk afterwards. MLX probably should be higher. There's some configuration questions there. I didn't run them all like 5 times. This is just something I did in my spare time. So this is looking at speed, which I think is another interesting thing. And again, depends on your workload, your situation. If you're making something for your company or multiple people, you care about concurrency. If you're making it just for yourself, maybe you only care about single user. So, and you'll face different trade-offs around accuracy versus speed depending on if you care about concurrency or not. So like this line through the middle is like, it's great at both concurrency or single requests. Something down here, like the MAMUTPP kind of formats, they're more on the single request side. They got great accuracy. Something up there, maybe NVIDIA's like professional floating point 4, maybe it's better for concurrency, actually not as good for single user if you only care about single user. And then again, it matters, like in my mind, efficiency is like where do you get the right balance for you of speed and accuracy. In this graphic, I just looked at like a single request, so kind of bars of how fast it is. And this actually is in tokens per second, for at least on my hardware. And then we talk about kind of accuracy on this side. So And I think I'll get to the takeaways, but I've always been really impressed with this format, AWQ. It's a post-training quantization thing. You give it a calibration data set. It can kind of dynamically pick which of the weights and layers are more important than the others. So it's not, I guess I should have covered that. It's not actually flat 4 bits across every weight. It's dynamically using a calibration data set to figure out which one's most important. So AWQ is great in terms of balance, right? It's not as accurate as you could get in high accuracy, but it is incredibly fast. So it's a good efficiency, I think. Yeah, so takeaways. 4-bit doesn't just mean 4-bit, right? Like I said, there's at least 9 different ways of calling it 4-bit, and there's always new ones. Like, we went to this AI conference and basically couldn't walk from booth to booth without somebody saying, I have a new way to compress LLMs. Well, of course you do. Everyone does, which is great. It's awesome. So at least in my opinion, like I said, for now, and things change very quickly. And a lot of it has to do with optimizations and the different kernels and the way you can do matrix multiplications. Not a math person. I'm more of a systems person. What can we do with more with less? But AWQ has always impressed me in all of the benchmarks I've run and the hardware I've had access to, both in the server world and local. NVIDIA-4 does show promise. Again, you need an NVIDIA card from this year to even run it natively. But in concurrent situations, it does perform pretty well. Similar accuracy to AWQ. Apple, interesting to me because, so like if you've got a cutting edge, top of the line Mac Studio, you can actually run DeepSeek at home, 4-bit, but it does not do concurrency the way you can get out of NVIDIA cards, even like gamer cards, definitely workstation. So on Apple, based on, and this actually surprised me because before I kind of did all this testing, I was always like a MLX, like Apple framework is the way to go. But MAMUTPP on Apple has come a long way. Like you can do a lot more concurrency now than you can on MLX, so that impressed me. And of course, accuracy is great, you can add some options. Okay, yeah, so ran through a lot. Data, like I said, it's on GitHub. Ask me questions, send me emails.
Great talk. Hey, could you speak to some specific use cases where you've been running actual model like outputs through the 4 bits and getting something in the real world that you're using and some better about?
Sure. So, like I said, we're a nonprofit. A lot of the stuff we work on, we work with interns, we work with apprentices, we work with community groups. A lot of the AI requests and community programs we've been doing this year revolve around language, so like Hawaiian language. Some of it multimodal, definitely multilingual. So we've had a few researchers that come to us with questions about like helping English-speaking researchers access data in MAMUTPP more easily. So like, just a treasure trove of information from 200 years ago. And so like we had this one researcher from UH, who's a sociology researcher, that was like, hey, I want to know like what famine conditions were in this particular community in this particular page, year range. Is there some way AI can help me search MAMUTPP better, right? Than like just checking the queries. So we've been experimenting, and for those kinds of queries that require like very high skill and multilingual, cultural context, historical context, we really find the best results from the biggest models, the biggest, slowest ones. So we run it on the max. Another example where we get a lot more use out of concurrency and can use a much smaller model. So there's a lot of interest in like how can AI help us with things like legislation and like getting, I guess, the public more plugged in with like what goes on at the ledge and all that kind of thing. And so we have a group that we help out that does food security advocacy, so anything related to food policy. And they asked us if, one of the things that we get, because we have a system that can connect to their RSS feed, the state RSS feed, but there's this irritating thing where it's like, if it's moving from one committee to another, or whatever those different statuses are, it's written by a person. It's not like computer generated of, it's going here and it's always this. What we ended up doing was, can you have a relatively small, it doesn't have to be that smart, but quick LLM like categorize this, like following these heuristics. So those are just a few examples of projects that we've put into the world this year.
So is the desire to use local models built from distrust of OpenAI and large companies, or?
Great question.
Yeah.
So we have a few partners that care a lot about data sovereignty, and even more so than and even on par with data sovereignty, this idea of compute sovereignty. So we do a lot of work with Nation of Hawaii. They care a lot about self-reliance. I would say it's not necessarily a huge priority to say like, I don't want to run my model in Azure, I don't want to run my model in Bedrock, but if I have the choice to host my hardware, if for $10,000 I can have a Mac that can run it, and I can learn how to do it myself, and I can be self-reliant, and that's, you know, if I don't have to send my dollars to Microsoft and I want to. We hear that from some of our community partners, and I think that was part of the impetus in like, how can we set up a lab like this? How can we help community organizations that do have those values make those decisions? What's the decision framework? I think the other part is like electricity use, and so part of that is there's maybe distrust or uncertainty around how much electricity data centers use. If you already have hardware or you have the ability to host hardware, then you have more control over how much you spend on a certain model. You can run a smaller, more efficient model if your workload doesn't require the fanciest, smartest. Now, similarly, you could call out to the cloud for smaller, but I guess you just have less control. So I think that's how we've heard from their community partners' interest in why you might run local models for most of those.
Is there any aversion to running cat-use models?
I've heard that from a couple, more from the like provenance of the training, more so than, I don't know, something might be hidden inside. But we haven't run into anybody that's told us you can't use DeepSeek, you can't use Qwen, but I have heard from some people that run companies that they've heard that from their customers that it has to be. Some folks say it has to be made in Europe even, but that's not so much.
Yeah, I already mentioned you can run some of the better models on a Mac Studio. Other than like hardware getting better, what do you think needs to happen so we can run it on our like mobile device? Other than hardware getting better, like in the AI space.
So you can. So I know Ben blamed me for why we didn't talk about Whisper CPP on phones, but you totally can, and we have, and it's even been able to for more than a year. It does depend on so a lot of these things with running on a Mac or running on a phone depends on how patient you are, right? So like, I was mentioning some of these cases where we need like deep historical cultural analysis and we run it on a Mac, but we can run it overnight. That's like a batch use case. It's like preparing a report that we're gonna go talk to our linguist about. Or something like, if you imagine like, is ChatGPT like deep research? Like, you know you're gonna wait 30 minutes, you know you're gonna wait an hour, or you go away and come back. It's, at least in my experience, it's similar on the phone, where it's like if you don't have the expectations of how fast ChatGPT is or Claude or something, and you find value in having it accessible offline, then yeah, you can totally run things on the phone. You can run smart things on the phone, you'll just be waiting longer. And I think that's super powerful. Like, I've been stuck on an airplane and didn't have Wi-Fi and had to try to figure out how to solve the problem, and I had an AI, I had an LLM on my computer. It told me how to do it. It's like talking to a chatbot without requiring internet. So I thought that was cool. I think to your question of how long will it be, you know, hardware gets better and better. Software also gets better and better, but our expectations grow too. Right? So we'll always get something faster and smarter from the cloud. But I don't know. I think I think even now you can have something smart enough that's interesting to be useful on your phone already if you're patient.
Thank you.
So like GPT-5 is sort of a router, right? Like you don't see a drop down that they used to show us. Is there anything in OpenAI that's trying to do something like routing between these things, embodying some of the decision making that you've shown?
Yes, and I think even stuff like again, right? Like both of these guys talked about how they do model routing, and there's purpose-built models for it in addition to like workflow-based. So, yes.
What's the word? Like if I were to Google for this, what is it? Just the word router?
Yeah, model router.
Router.ai.